This video is on the topic of how to link the number of moles, the mass, and the relative formula mass of a substance. You should remember that the amount of substance is measured in moles, where 1 mole of a substance contains 6.02 times 10 to the power of 23 particles, and that this number is known as the Avogadro constant. You should also recall that molar mass means the mass of 1 mole of a substance, and it is measured in grams per mole. You need to be able to calculate the number of moles of a substance in a given mass and vice versa. So you need to understand the relationship between mass, moles, and molar mass, which is shown in this equation triangle. From this triangle, we can see that the mass of the substance is equal to the amount of substance in moles multiplied by its molar mass in grams per mole. Using this triangle, we can also obtain these two further equations linking these quantities. You should recall that 1 mole of a substance has the same mass as its relative formula mass written in grams, which means that the molar mass of a substance can be calculated by finding the relative formula mass of the substance in question. This means that the relationships shown in these equations are often written using relative formula mass instead of molar mass. For example, the first equation shown can be written as mass equals moles multiplied by the relative formula mass. Either way of writing these equations in an exam is accepted. It is really important that you learn this relationship thoroughly, as you were not given the equations in exams. This relationship can be used in a number of different ways, so we will look through some worked examples to demonstrate some of these. This question asks you to determine the number of moles present in a given mass of a substance. The relationship linking mass and the number of moles also requires the molar mass, so the first step is to find the molar mass by calculating the relative formula mass of the substance. We do this by adding up the relative atomic masses of all the atoms within the compound, which contains 2 atoms of sodium, 1 atom of carbon, and 3 atoms of oxygen, giving a relative formula mass of 106, which will gain 1 mark. Remember that you should use the periodic table to obtain the relative atomic masses of each element. Write down the equation that you need to use. The mass is given in the question. Remember that the mass needs to be in grams, which it is in this question, but in other questions you may need to convert the mass to grams. We can use the value of the relative formula mass for the molar mass that we have just calculated. Then substitute the numbers in and calculate the final answer. Remember, you can replace the term molar mass with relative formula mass in the equation to calculate moles. In this question, you need to calculate the mass of a substance, and you were given the amount of substance in moles. As with the previous question, the first step is to calculate the value of the relative formula mass. Nitric acid contains 1 atom of hydrogen, 1 atom of nitrogen, and 3 atoms of oxygen, which gives the value to be 63. Next, write the necessary equation. The number of moles is given in the question, and we can use the value of the relative formula mass for the molar mass. Substituting in these values, we can then calculate the final answer. Remember that when you use this equation, the mass will be given in grams. This question asks you to calculate the mass of 1 atom of magnesium. You know that the relative atomic mass of magnesium is 24, which means that 1 mole of magnesium has a mass of 24 grams. So 1 mole, or 24 grams, will contain 6.02 times 10 to the power of 23 atoms. To calculate the mass of 1 atom, we need to divide the mass of 1 mole by the number of atoms in 1 mole, which gives us this value, which has been rounded to 3 significant figures. This is the type of question that students frequently get wrong, despite the calculation being relatively straightforward. Make sure that you check that your answer looks sensible. A common mistake is to multiply 24 by Avogadro's constant instead of dividing by it. This would give a really large number, which can't be correct, as you know the mass of the atom is tiny. In this final example, you are asked to calculate the number of molecules in 10 grams of a substance. To find out the number of molecules, we must first work out how many moles there are. So start off, as we have done in previous questions, by calculating the relative formula mass. Write down the equation to find the number of moles. Substitute in the values for the mass and molar mass using the relative formula mass that we've just calculated. This is not your final answer, so don't round the answer at this stage. The number of molecules can be calculated by multiplying the number of moles, which we have just calculated, by Avogadro's constant. This gives us our final answer, which we can now round. In summary, the amount of substance in moles is equal to the mass of the substance divided by its molar mass. The molar mass is found by calculating the relative formula mass of the substance. This can then be used to calculate the number of moles in a given mass of a substance, and vice versa.